So for letter A, did you get, was it 17? I think I have that one memorized. I think it would be 17. 225 plus 64 and then square root, yeah, 17. For letter B, did you get 5? Okay, those are the right answers. On your test, being your final exam, if they ask you to leave in simplified radical form, you might have to break down the radical. Of course, it will be multiple choice, so you'll have to just look at the best option of the 4 choices that are there. Whoops. Okay, on to this one now. Copy this down. The converse takes the entire statement and just reverses it. So now it says, if the sum of the squares of the measures of 2 sides, the 2 shorter sides, of a triangle equals the square of the measure of the longer side, if that's true, then it is a right triangle. Obviously, we know that the hypotenuse is always the longest side, so it's that one that stands alone. All right, to test it, you are going to do this, and you're not going to put an equal sign here, not yet. We're testing to see if it's equal. Okay, so you're going to start with C. This is why I recommended that you started writing it C squared equals A squared plus B squared. Yeah. We're going to take C squared, and that's always going to be represented by the longest side, and we're going to compare that to, I put a line to compare them, compare that to A squared plus B squared. We're going to decide if it's a right triangle or not. If it's equal, or if it is less than, or if it is greater than, because that's why I was telling you that when we don't work with equal signs, then the order starts to matter, that it could be greater or it could be less. So C squared is the test to you. So over here, which letter could represent the C? The biggest one, the 25, that's right. Make that one equal to C. Now, we did last semester where 2 sides always have to be longer than the third side. So let's make sure this triangle even exists. 20 plus 15 is 35. That's bigger than 25, so this triangle is good. It exists. Okay, so we're going to start off with the C squared. You don't have to write this every time. You just have to do this order, but I'm going to write it so you know where all the numbers are coming from. So I'm going to try 25 squared on this side. And over here I'm going to use the other two in any order you want. 20 squared plus 15 squared. And you're going to want calculators, and you multiply this out, you use PEMDAS, and you compare this side to this side. So 25 squared is 625. And then that's 400 plus 225. That comes to 625. So now that you know both sides are the same, you can put an equal sign here. And you can say, yes, it's a right triangle. Right triangle. There will be times, though, where it's not a right triangle, and that's what I'm going to show you today. Any questions on that example? Okay, now if you do it in the order and the steps I show you, then this next part is extremely easy. What is an obtuse angle? Bigger than 90, right? So what do you think an obtuse triangle is going to be? This angle, the angle is going to be bigger than 90. That's right, okay? So we're going to be looking for a greater than sign. So look at this chart right down here. The Pythagorean inequalities theorem. If C is the longest side of any triangle or of any set of numbers, then check the following. And we're always going to test it. And you don't have to write this down because you already have it written just above. But we're all going to test it this way. So if we end up with C squared is equal to A squared plus B squared, if that's what we end up with, finding out there's an equal sign there, then we can call this a right triangle. And that's what you've been working with most of, well, since junior high anyway. Pythagorean theorem. But now, if you put the C squared first, and you end up figuring out that C squared is greater than the other side, C squared is greater than the other two sides added together, then what do you think it's going to be? If it's greater than a right triangle, what's it going to be? It's an obtuse triangle. Yep. but only if you put c squared over here. If you write it the other way, the sign reverses and it gets confusing. Some people can see it that way, and that's fine as long as you don't mix them up. So then this one's going to say if c squared is less than what you got on the other side, the a squared plus the b squared, then what kind of triangle is it going to be? It's an acute triangle, that's right. Okay, so that's what you need to know for today. So let's do the bottom three examples together. Let's make sure you know how to write the letters in order to test it, and then time work. Tell whether the measures can be the side lengths of a triangle. So first of all, we have to figure out yes or no. Look at this one. The two smaller sides are 15 and 18. If you add those together, is it bigger than 20? Yeah, so we can do that kind of triangle. Add these two together, the smaller ones. 8 and 7 makes 15. Can that be a triangle? Yeah, 15 is bigger than 11. And test this one. 6 and plus 8 is 14. Can that one be bigger than 10? Yes. Okay, so if the triangle exists, we have to now classify it. Give it a name. Please don't ever give something a name if it doesn't exist. If a triangle can't exist, don't call it acute, obtuse, or right. Okay, so which letter stands for C? The 20. That one's C. So I'm going to do 20 squared. And I'm going to compare that to 15 squared plus 18 squared. Some of you can do this all in the calculator. Please go ahead on your calculator, figure out 15 squared plus 18 squared, and let's see what we get. I know this is 225, and then I think that one's 324, but what are you getting?
549.
549, excellent. So now we look at that. Do I put a greater than sign or less than sign? 400 compared to 549. I'm sorry, 400 compared to 549. That's less than. 400 is less than the number 549. You see how that works? The open end goes towards the bigger number. So, what kind of triangle will we call it? Acute. Less than 90 is acute, so it's an acute triangle. Okay, and that's all there is to it. Letter D. Which one stands for C? 11. The biggest one of the three. So now we do 11 squared, and we compare that to 8 squared plus 7 squared. You can write that all out, but I would rather not. I just do it on the calculator. What's 8 squared plus 7 squared? 60. What is it? 113. 113. 64 plus 49. Good. That one's greater than. 121 is the bigger side. 121 is greater than 113, which makes it an obtuse triangle. And letter E. Which one stands for C? The 10. Good. So you have, if that's C, then you start off with 10 squared and you compare it to 6 squared plus 8 squared. 100 on both sides, right?
Yeah.
So since those two sides are equal, we call it a right triangle. And that's it. That's the only new thing we need to know. But that's why I always start with the C squared first. Because it makes the less than sign fit acute, and it makes the greater than sign fit the obtuse. Questions on that?
No.
Okay, turn the page, look at the bottom side, or the bottom half. The lengths of the sides of the triangle are given, classifies acute, right, or obtuse. First of all, does the triangle exist? Let's check. Two smaller numbers are 3 and 4. Is that big enough to overlap a 6?
Yep.
Yeah. All right, 11 and 13 makes 24. That can overlap 16, right? 4 and 2, can that overlap a 7?
No.
Good, so this one's not a triangle at all. So you can't give something a name if it doesn't, well, that's not true, but don't give a triangle a name if it doesn't exist. Because the 4 and the 2 only makes 6, and that's not big enough to overlap a 7. Okay. Obtuse? Good, for 13 did you get acute? All right, so go ahead and finish number 15.